something on history, but history of called first nonlinear functions in econometrics. Okay, and because we always do linear regression, and it took a long time for econometricians to switch from say linear to nonlinear. Okay, because there is a big reason for that. Okay, next slide, please.
Sorry, sir.
Next slide.
Yeah, sir. Sorry. Yes.
Oh, yeah. So, I mean, people have a very kind of misconception of history. By history, people mean dates, names of the people, kings, queens, and places. History is not really just names and dates. And the way I will kind of tell that history is a kind of a dynamic process of causes and effects, and there is a lot to learn from the history. Next slide. Okay, as I said, that there is a huge difference or a big jump when you move from linear model to a non-linear model. It is just not a one step. In fact, it is not so easy to define what is a non-linear model. So I think to define it, we need a lot of help from a guru. Next slide. Okay. So this is one of my gurus. So those who cannot recognize him, that is, Leo Tolstoy. Okay. So let us see what did he say about nonlinear model. Next slide. Okay. If you can recognize this line, it is the first line of his very famous book, Anna Karenina. Okay. What it says, all happy families are resembles one another, but a family is unhappy in its own way. And exactly same way, all linear models are basically resembles one another. The linear line is linear, that's it. But when it is non-linear, what we can say, it is non-linear in its own way, because non-linear can be quadratic, some other higher power, or it can be, there will be a lot of ups and downs. Okay, so non-linear model is a much more complex. Next slide. Okay. And what I'm going to talk about, this a non-linear function called non-linear production function, which is known as constant elasticity of substitution parameter production function, something known as CES production function. I'm sure all of you have used this, CES production function, many times. It is everywhere in microeconomics, macroeconomics, international economics. This particular function, although it started as a production function, but people can use it for representing any other function. So if you remember correctly, that this paper was written by 4 people, Kenneth Arrow, Hollis B. Chenary, and then Minhas. You can see that I have bold Minhas' name in a bold. There is a reason for that. And another is the Robert Solow. And out of these 4 people, 2 of them got Nobel Prize, Arrow and Solow. And Chenary, of course, the very famous economist. He was the chairman or chief economist of the World Bank. But this other person, Minhas, is pretty unknown to the outside world. Okay, and 3 of them died already. Solow is still alive. As you can see, he's very old, and he's going to be 100 years old in 3 more years. And so, but again, this history is not anywhere, but I found the history from different sources. 2 of the main sources, I had a big interview with Kenneth Arrow. And then I looked into some kind of, diaries of Minhas. Okay. And my talk will be more connected with this guy, Minhas. Next slide. So this is the guy you can see in the picture, and he's Kenneth Arrow. This is in his office. And you can see his office, how nicely organized the office. And because while we are talking, and sometimes he needs some a piece of paper or another one of his own paper, he can just put under the pile and can he pull out exactly the paper that we needed to talk about. So although it looks messy really, but he's a very well organized person. Next slide. Okay, so this interview took on more than 10 years back. As you can see, this is an email that he sent to me. And because I was worried, that time he was also very old and I didn't take up much time. So I wanted to meet him only for a very short time. But then he said, no, don't worry, he can manage it. That's what he wrote, that I am sorry for your anxiety. That is Kenneth Arrow's writing. Then we met one Monday, as you can see, at 2 p.m. And this was supposed to be only half an hour meeting, maximum. But, when the meeting finished, it was already 4:30 p.m. Okay, so we had a long meeting and he told me a lot of things. And that's what I'm going to share with you. Next slide. Okay, now just to recollect your memory, and I am sure all of you have done this 100 times, the mathematical expression of the CS production function. So V is the production, L is the labor input, K is the capital input, and alpha and beta are the two parameters. But look at one main parameter is rho. Okay, we'll talk about rho. And as we know, the Cobb-Douglas production function is a special case of CS production function. Basically, you put rho is equal to 0, then you will get from CS to Cobb-Douglas. Again, rho is equal to 0 means that if you see the symbol sigma, sigma is equal to 1. And sigma is known as the elasticity of substitution. Okay, and so as you can see that the Cobb-Douglas production function, it looks non-linear, but you take the log of both sides, it is a linear function. Now the log of V basically is linear in log in L and log in K. Okay, so Cobb-Douglas production function is a linear production function. But now try to take the log of CES. No, you cannot take the log. No, because even you take the log, nothing much happens. It still remains highly non-linear. Okay, and again, I am going as if there is no question, but I will give you the option. If there is an option, you can ask me question. You can stop me at any time. From Ufuk Bengal, he can also allow you to ask any question if that option is there. I am open to any question at any time. Okay, so these are the two very known things that we know. But what I'm going to talk about, the Cobb-Douglas production function kind of started like 1930s. And it took another 30 years to get CS production function. And why it took so long. Okay, and that is the story that I'm going to tell you. Okay, next slide. Yeah, we can skip this because these are all kind of literature survey. So maybe I don't want to, we lost some time. So, okay, yeah, skip this slide. Next slide. Okay, next slide. Yeah, okay. We can skip this slide because this is about little bit of, how did I get into the CS production function? But this is not about the CS production function. This is like my own story. So we'll skip this. Let us skip that. Skip this. Skip this. Skip this. Skip this. Skip this. Okay. Yeah, here we are. So I going to talk about particularly this person, Bagicha Singh Minhas. You remember, he is the one of the authors. And as you can see the name, a Bagicha, I think Bagicha is a Turkish or the Persian word. And Bagicha, and as you can guess, it means garden. No, Bagicha in Turkish, I think you call it a garden. Okay, so and he comes from a agricultural family. Okay, and his last name is Minhas. Again, Minhas is not exactly an Indian name; it is a Persian name. So maybe his family came from Persian or Iran, and then Singh is the only Indian part. So he came to this my university where I am, University of Illinois Urbana-Champaign, as a PhD student. Okay, and but he didn't join the economics department. He joined the agricultural economics department because he didn't have any background in economics. His background was more like in agriculture. Okay, so that's what happened. And so he joined the agricultural economics department. And in India, he did something like, this agriculture in terms of soil science and all those things. And that means he didn't have any background what we require in proper economics, like mathematical economics, micro theory, macro theory, and econometrics. He didn't have that background. So he joined the more applied agricultural economics department, which started like 1933 in UIUC, where I am right now. Next slide. Okay. And he joined in 1955 to the agriculture department of Illinois. Now you might wonder why he did, came to Illinois to do agriculture. So as you can recognize, this is a guy, I am my another guru other than Leo Tolstoy. This is Rabindranath Tagore. I am sure all of you are familiar with this from your previous president, Bülent. Okay, I think Bülent Ecevado. Okay, who is was president twice, I think, of Turkey, and he translated many of his poems into Turkey from my language, Bengali. So what Tagore said about agriculture at Illinois, Tagore was in Illinois, University of Illinois Urbana-Champaign 3 times. And when people asked him, what does he think about University of Illinois? And this was his response. Next slide. Okay. Because Illinois, the university was started as an agricultural university. So everything in this place is all agriculture. It is a rural place, and the university is completely surrounded by the fields like corn fields and soybean fields. So agriculture essentially is the main thing of this town, Urbana-Champaign. So Tagore jokingly said, there is just too much agriculture, but no culture. Okay, so agriculture was a main thing, and it is still a main thing. So students, they come from all over the world to do the their agriculture. Okay, so agriculture is a big thing at the University of Illinois at Urbana-Champaign. Next slide. Okay. as I was saying, that what was his background before he came, his first part was agriculture, pure agriculture. Then he finished a master degree, but then the standard of the master degree in India at that time was very, very low. Okay, and then he was teaching in a kind of college called Hoshiarpur College, which is very kind of small college in the area of Punjab. Okay, so that was his background before he came to University of Illinois in 1955. Next slide. Okay, so as you can see, this is the University of Illinois, the Agricultural Economics Department, what is known as called, Mumford Hall. So that's where the Agricultural Economics Department is. But again, this department was a breakaway from the Economics Department. Okay, so the Economics Department was split into two parts, and here is the Agricultural Economics Department part. Next slide. So this is where the economics department is. Okay, it is called Ohlars Hall during that time. Okay, but as you can see, these two buildings and two different cities. Yeah, if you have noticed, the Mumford Hall was in Urbana city, and this is in Champaign, because you have the two in city, Urbana, Champaign. But these two, two buildings are just separated by, few hundred, maybe 100 years. So it is the same, place, but they're separated. Excuse me. Okay, so this is the economics department. Okay, next slide. Okay, now what happened? The courses those are offered in agricultural economics department are very limited. So even the same practice is still being followed. All the PhD students of agricultural economics department, they had to take micro, macro, and econometrics from the economics department and pass. They don't have to score a big score, but they have to pass the this economics department first year PhD program. And then one of the course gave him lot of trouble is this called micro theory course. And micro theory course was taught by this guy called Hans Brems. He was my colleague for many years. Then he passed away in 2000. And he was a student of Leontief, but he was more like a mathematician. But as I said, Minhas, the graduate student from India, he didn't have any background in mathematics. So he had a lot of trouble following particularly this micro theory class. Next slide. Okay, so this is Hans Brems. Okay, and now he came from Europe, and as you can see that he was University of Illinois. First he taught at Berkeley, then he came to Illinois, and he was more like mathematical economist. So his course was very rigorous course, and which Minhas found it very difficult during his first year. Next slide, please. Okay, so that's what I just said. Without any math and stat background, the courses at Illinois, the economics department was really hard for him. But anyway, the Hans Brems covered the production function. So you can see the connection that I am talking about. The production function, again, the CS production function. But we have to give a credit to Hans Brems that Minhas got somehow interested in production function. But again, I will tell you, not from his class, from some other way. Okay, but there is a connection because he heard or he learned whatever little bit of mathematics about production function that was from this Hans Brems class. Next slide, please. Okay, so Hans Brems taught this, Cobb-Douglas production function. So all of you know Cobb-Douglas. Okay, so I won't spend much time in Cobb-Douglas production function. Okay, all of you know this. Okay, so it was first published in 28, then few more papers came in 1930s. Okay, so but let us skip this date. 1928 was the first calculus production first appeared, then Leontief production function appeared in 1953. Okay, next slide. Okay, so yeah, I just said next slide. Okay, let us skip this slide. It is all surveys. Okay. Okay. Now let me just say about this guy, Douglas. Cobb Douglas. Douglas was a politician, but first he started with his, he studied University of Illinois. Then he went to University of Chicago. Then he became a senator. He ran from president, but he lost the primary. So this Douglas has a very, what you call, root in Illinois. Okay, and in fact, he taught at University of Illinois. He started his teaching career at University of Illinois. So what I'm trying to say, the University of Illinois is basically, the kind of has connection with the both Cobb-Douglas production function and the CS production function, as I will explain later. Next slide. Okay, this is about Cobb-Douglas. So let us skip this. Okay, so when Hans Brehm taught Cobb-Douglas production function, and he basically said, this is the kind of the best production function. It has passed the test of both theory as well as empirical scrutiny. So that was his last word on production function, the Cobb-Douglas production function. Okay, so that was the Hans Brehm's, conclusion of his, lectures that he gave. And in fact, I have seen Hans Brehm lecture notes. It is all mathematics, but essentially saying, okay, Cobb-Douglas production function, that's it. You are done with the production function. Okay, yeah, next slide, please. Okay. Now, Minhas, as a graduate student, he learned Cobb-Douglas production function as if that's the only thing that you can do as far as the production function is concerned. That means there is a unique production function which will fit everything. Now, he observed something completely outside the class. Okay, as you can see, I'll go into detail about this because what I'm trying to tell you the following, that a lot of our PhD students, not only PhD students, even the junior faculty, assistant professors, lecturers, always kind of struggle to find a research topic. And even myself, sometimes we look for research topic and we look into textbooks, or we sometimes look into Econometrica, American Economic Review, famous journals to find new ideas. Now what I'm going to tell you, that to get new idea, sometimes you have to go beyond the classroom. In fact, the research ideas are scattered everywhere. Okay, and here are two very unlikely places I'm going to mention about research idea. What Minhas observed. Minhas observed two things. One is the barber shop, and another is called, the farming. I said, the University of Illinois is in the middle of the corn fields or corn and soybean fields. And when a student comes, they are connected with a host family, who that host family basically introduces a student, a foreign student, into the culture and lifestyle of the, United States. Okay, so they're like a local guide. They're not academics at all, but it is, they help the students. So he observed something in the host family. Next slide. Okay, barber shop. So this is the barber shop Minas was familiar with. This is in India. Okay, can you see this? Two pictures. And in India, when you go to any barber shop, for hair cutting, they ask you two questions: what kind of style you want, Romanian style or Italian style? Romanian means your hair will be cut inside the room. Now, can you see the picture on your left hand side? That's the Romanian side. And the other side, you can see on the right hand side, that is done outside the room. And it is called Italian because, as a customer, you sit on a it. It means brick. Okay, so that's why it is called Italian style. Okay, so India, we have this style, two style. Okay, and you will understand why I am going through this kind of thing, but it will be clear. Okay, so this is the what Minas was familiar with, hair cutting. And here in India, they will take a lot of time. They do it very carefully, and the charge will be very, very, very minimum. Okay. So the next slide. Now look at this one. This is the same process, hair cutting, and this will be in Urbana-Champaign, the saloon will look like. So you can see the distinction between, Indian style of hair cutting and the American style of hair cutting. Okay, so the next slide. You can see, this was I was when I India last time. This is the place I cut my hair. Okay, but again it is in the room. Can you see this is Romanian style? Because when I was back in India long time back, I could not afford to pay Romanian style cost. I always used to have an outside the Italian style. Okay, so the next slide. Okay, so if you think about the Indian style, the cost will be maximum $1.4 or 70 cents. Okay, current price. Okay, and in India you get a very good service. They will spend at least 30 minutes to do this hair cutting. Okay, and they will do a good job. Even they will cut your beard, save your beard as a bonus in addition to cutting your hair. Okay, very good service. But in UIUC campus, what Minas saw, the cost is expensive, currently it costs $20 minimum. Okay, and service maybe maximum 15 minutes. And India, they use the scissor to cut the hair. Here they have little mechanical tools, to call clipper. Now think about hair cutting as a production. No, it's a service industry. It's a production. No, service is a production. Now Mina started asking this question that if hair cutting is a production function, then the way it is done, the output is the same, cutting the hair. The output is the same, but the labor and capital is, the way it is used is completely different. In India, it is more capital. There is hardly any capital, just a scissor, but lot of labor, and it takes a lot of time. But in the UIUC campus, not much time, very quick, but they have a lot of tools, lot of capital. So that means he started asking the question, what he learned in his class, that there is only one production function, that is Cobb-Douglas production function. And in the Cobb-Douglas production function, the capital labor substitution, remember the symbol sigma? Sigma is always 1. or it kind of, this capital labor is kind of almost perfectly substitutable. Okay. Then he simply asks, Cobb-Douglas production function has the elasticity of substitution exactly equal to 1. And then he found out that the hair cutting, capital labor, the way it is mixed is completely different. That means the hair cutting in India must have a different production function than hair cutting in the United States. That means there have to be 2 different production functions. Okay, so that is the question he was trying to ask. There may be one may be Cobb-Douglas, then other cannot be Cobb-Douglas. Okay, so as you can see, this idea of a different production function didn't really come from Hans Brem's lecture notes or what he learned in the class. So this prompted him to think more about production function, or more specifically beyond the Cobb-Douglas production function, which had been used for like 30 years extensively in economics. Okay, so this is the hair cutting. Let us look at another example more close to agriculture that I was talking about. Next slide. As I said, when the University of Illinois, it is a little town, middle of nowhere, and the town is completely surrounded by corn and soybean field. So here is an Indian graduate student, was completely kind of mesmerized with the huge cornfield around the university. Okay, so she's a PhD student, so I just got the picture, So I just to show the importance of agriculture, and in particular the cornfield. Yeah, UIUC. Next slide. Okay, now how is corn is produced in India? You won't believe, in my village, people still use this same plowing method with plow and the bullock. Okay, so this is that even now. So you can imagine during Mina's time, it was the same technology, to plow the land. Okay, then let us look at in US. Next slide. Okay, so this is the US method, of plowing the land. Okay, so next slide. So again, he found that production of corn was so different from India to the Urbana-Champaign place. In India, the Minas family, this is exactly, he wrote in his diary that he had 18 acres of land. There are 3 laborers, his father, uncle, and a granduncle, and then they have a pair of oxen for plow the land. So 3 people were engaged to produce a corn on a land of 18 acres. And whatever they got even was not enough for the family. But in the Illinois, in his host family, they had a 450 acres of land. And 450 acres, just see the comparison. And only 2 labor units. The person, man, who was the host family, husband, and his wife. But they had this, big machine, the huge capital. And 1955, I can tell you, I checked, the price of the corn was very similar to the price of the corn in the United States, also of the soybean. And not only that, the exchange rate between the Indian rupees and the US dollar was very similar. Like $1 was or more or less 1 rupees. And you won't believe, just like as you are experiencing Turkey, the exchange rate now, $1 is around 73 Indian rupees. Okay, just 70 years back, they're equal. I remember when I was in Turkey first time, $1 was, I think, 2.4 or 2 Turkish. No, and now the exchange rate. Okay, so but what I'm trying to tell here, the prices were same, but the way the production of corn worked in India and Illinois is completely different. In India, it was completely labor intensive, but in Illinois, it is mostly capital. Like two people producing corn from a land of 450 acres. Again, he asked the same question, that there must be two production function for corn, one in India, one in US. So if it is Cobb-Douglas for US, it cannot be Cobb-Douglas for India. So he thought there must be some other production function. The question is what it is. Next slide, please. So this is what I just mentioned, that the comparison of hair cutting or agricultural production are so different in India and in US. Then he connected what he learned in Hans Brem's class, because he learned Cobb-Douglas production function and the Leontief, because Leontief is not a very practical production function, because there is absolutely no substitution. Okay, so that he already ruled out. Okay, so he started asking this question: what would be the other production function, and to see whether Cobb-Douglas is really a good production function, what he learned in the class. Next slide. Yeah, next slide, please. Okay, so as you know, the first year I was saying that he was so busy in his coursework, no time for research. So he came here in 1955. Okay, so first year, but in fact, as far as I know, he barely passed. In fact, he failed completely in microtheory. Okay, but then, for agricultural graduate students, they didn't have to get a high score in econ subjects. The econ PhD students, they have to have a good score. But agricultural economics, if they barely pass, that's enough. Okay, so then he got this idea that maybe he can do something about the production function, but not knowing what. So he did some reading on the summer of 1956. Okay, and so then he thought he should try to look at empirical work, fitting Cobb-Douglas production function with different kind of data, because he didn't have much theory, so everything was more like an empirical for him. Okay, next slide. So then he thought he should learn a little bit of mathematics. So he read this book, R.G.D. Allen. It's a very old book, but that was the only book during that time on mathematical economics. And then because in Cobb-Douglas, you don't study the elasticity of substitution at all, because elasticity of substitution is exactly equal to 1. You cannot do anything because it is set to 1. So there was no discussion of this elasticity of substitution in Hans Brem's class. Okay, but in R.G.D. Allen book, there is section on this elasticity substitution, how it is defined, what is its interpretation, and so on. So he learned a little bit mathematical underpinning about this sigma, elasticity of substitution. Next slide, please. Okay, so this is his kind of, the seed of his ideas. That this capital labor ratio, in response to the wage capital rental ratio. No, that is the elasticity of substitution. That it cannot be same in hair cutting or in producing the corn in India and in Illinois. So that is, look at the idea he got. That's what I call conception, of CS production function. And so this is kind of, is not an idea yet. He said, no, that the sigma cannot be the same in Illinois and India. If sigma is 1, that's what people are assuming. All the production function that has been fitted, in agriculture or in factories, all Cobb-Douglas production function. Then he saw, that what could be in Punjab means, what would be in Indian situation. Okay, so he started in some sense questioning the Cobb-Douglas production function, which has already been accepted by people. Next slide, please. So this is what he wrote down, in his diary. Okay, and as you can know, I can still remember my days. That was, in 1979. How many years? More than 40 years back, when I was started my graduate studies, PhD in Australian National University. Getting the idea, it's a kind of, it's a amazing experience. So when Minas got this idea, he got very excited. Okay, now what he wanted to do, it's a huge path breaking. Testing model was not, into the picture of econometrics at all. For many years in econometrics, it was just building a model and estimating the model. That's it. So people estimated hundreds of Cobb-Douglas production function and interpreted the coefficient alpha and sigma, and that was it. But now what he's asking, now it looks trivial, but that time it was almost kind of revolution, that he was asking to test the model. That means questioning the model, questioning the Cobb-Douglas production function. Okay, next slide. So then what happened, So he was not regarded as a good student at all because he did so badly in the coursework. In fact, he was in the bottom of the class. Forget about economic students, even in the agricultural economic students. Okay. But then he presented this idea of, doing something about production function in his comprehensive exam. What we call oral exam, or sometimes we known called qualification exam. Okay, so people listen to him. That's his idea of doing a thesis after barely passing the coursework, and people were not at all encouraging. They said, okay, we'll pass you. That's it. Nobody took any interest in his research idea. Okay. And so he was really depressed, and because he knew that he will not get any supervision. Nobody was willing to guide him. They didn't fail him, but nobody was, willing to guide him at the University of Illinois. Okay. And in fact, he was here 2 years. Remember, he came in 1955, summer. And now it is June 1957. He spent 2 years, and I tried to look at a record of University of Illinois. He has no record in University of Illinois because he didn't get any degree here. He just did the 2-year coursework at the University of Illinois. So as if he was never a student of University of Illinois. So he was highly, completely depressed and didn't know what to do. Then what happened, okay, now let me tell you something, another background. That time that Minas came to University of Illinois as a student with a scholarship, and that scholarship was given by United States government. Okay, United States government. And when they have the scholarship, the student can choose any economics department or anywhere agriculture to do his PhD or her PhD. So Bera first selected Illinois because Illinois had a big name in agriculture. That's why he came. But Illinois treated him very badly for whatever the reason. So, but Stanford now is one of the top university, but during that time, Illinois was a much better university than much more well established, at least in agriculture, also in economics. Because Illinois has a fantastic department, for many, many years. Okay, because it was a land-grant university. Okay, and why United States gave the scholarship to the Indian student? Because India was following the economic policies of Russia. Okay, like a 5-year plan program. It will be socialist type. And of course, America didn't like that. USA didn't like that. So to counter that, they said, okay, now the only way they can influence India's intellectuals by giving American training to the Indian students so that they will go back to India and follow a capitalist system. So that was the America's program. I mean, whether it is good or bad, that's not the idea, but that's the way it started. The Indian students started coming in 1950s because India got independence only in 1947. Then they immediately started following the Russian economic system, this planning method of economic progress. Okay, so Minas was free to go anywhere he liked, but he selected after he decided to leave Illinois, and he had the money, so he went to Stanford. But another reason for Stanford, because Stanford just started a big program, and that time economics was not at all quantitative. This program is still in Stanford. It is called Stanford Project for Quantitative Research in Economic Development. Remember, this is called quantitative research. Okay, earlier, as you can imagine, if you read the articles, 30s, 40s, all economic papers was, mostly empirical or lots of history, lots of institution. Math and sophisticated econometrics came, kind of from 60s. Okay, and the Stanford program was directed by, remember I said about one of the co-author, this Chanari, Hollis B. Chanari, and also this Houthecker was one of the most prominent, applied econometrician in 50s, 60s until 70s. So they were directing the program in Stanford. So he heard about Stanford. He said, okay, let me go. So he took a Greyhound bus and left Illinois and never came back here. Okay, so I think that was a big loss for Illinois, and we'll know why. Next slide. Okay, so anyway, so he has a lot of problem. Okay, this is in 3rd year in Stanford. Now almost 3 years is gone. 3 years is gone, and so end of the summer of 1958. Again, 1955 he came to the United States. He had some results, and he ran some simple regression. And the econometrician was there called Arthur Goldberger. Some of you might have read his textbook of Goldberger. So Goldberger gave him some guidance, and he got some data from 24 countries, industries, and 19 countries to run a regression. Okay, so let us see what kind of regression he ran. Okay, next slide. Okay, so he got the data and he ran this regression. Okay, now look at the independent variable. Okay, is the value added input. V is the total production and L is the labor. So this is the value added input. Okay, and W is the kind of the money wage rate. Okay, So this is the total cost, labor cost divided by L. Okay. Now imagine this. If it is a Cobb-Douglas production function, remember we said the substitution parameter is 1. So he formulated this regression with the help of Goldberger, not fitting the Cobb-Douglas. Because if you fit the Cobb-Douglas, your elasticity is exactly 1. There is nothing you can do. It is built in. So with the help of Goldberger, he started this regression. What this regression says, that if the production function is Cobb-Douglas, then your beta parameter should be equal to 1. No? Again, let us just loosely say perfect substitution. And again, beta is equal to 0, no substitution, that's a Leontief. So he wanted to see, because that time only 2 production function was known, Cobb-Douglas and Leontief. And this regression has 2 special cases, beta 1 Cobb-Douglas, beta 0 Leontief. So he thought, because remember, he wanted to test the validity of the Cobb-Douglas production function. So he ran this regression. Okay? Because that's all he could do, because he was not an econometrician, he didn't understand much of statistics, anything, but at least this part he understood, that for Cobb-Douglas, beta should be close to 1. Next slide. Okay. So he wrote a kind of, working paper. So he ran lots of regression with international data, US data, manufacturing industries, and all kinds of, and just looking for whether beta is equal to 1. Okay. So that means, again, he's doing testing, remember, which was completely unheard of during that time. Testing. Okay, next slide. Okay. We don't go now. This is the empirical work he did, and if you look at what kind of betas he got, I don't know, can you read? Ifuk, can you read these numbers from here, or you can increase the size?
Or actually, I may read with a small screen. I do already control on another computer. I may read the numbers.
Oh, okay. You can read the numbers. Okay, yeah. Okay. Now, look at the beta. The estimate of beta under the column B. As you can see, that the numbers are, some are very close to 1. Some are not that close to 1. One of them greater than 1. In fact, you can see the t-test, it is a t-test whether they're significantly different from 1. Yeah, some of them are quite significantly different from 1. Okay, so he said, with this limited exercise, he said, no, beta not. Okay, I mean, even one of them is not 1, that is enough to say that Cobb-Douglas production function is not the right production function all the time. Okay. So sometime, it was as low as, if I can go, if you look at the t-statistics, something, there are some of them are like, higher than 3 and so on. Okay. So it put some questions about the universal validity of the Cobb-Douglas production function. Okay, next slide, please. Okay. Now then what he did, he also some aggregated data. Okay. Now look at this aggregated data. Look at the beta coefficient is not 1. It is 0.752. Okay. So again, it kind of, with the disaggregated data, aggregated data from 43 countries, the result is not really completely in favor of Cobb-Douglas. Next slide. Okay, and again, I won't go through this, this is the data, he used from 43 countries. On the top means basically the worst country. It is the country with the least value-added per unit of labor. Okay, see, China was in the bottom in that sense. And you can see that the value added in China, it was $404. Okay, let me see whether, I think that time there was no data of Turkey, if I know completely. Let me see. Okay, yeah. So you can China was in the bottom in that sense, and United States is in the kind of top. China has a value added $404, and United States has $7,400. Okay, so China was like as bad as Iraq, Nicaragua, Pakistan, and so on. Okay, even Japan was not that good. So you can see that. So I think this data is very interesting data. Okay, and this data is just 70 years back. Okay, so now we know where is China and other countries. Okay, so so this is the data he used. Okay, and whatever was available from the World Bank that time, because Chenery was supplying the data from the World Bank data. So this data is pretty reliable. Okay, next slide, please. Oh, by the way, 1 second. Can you go back? Yeah, okay. No, I can see Turkey because even it is so small, I cannot even read. You can see Turkey in number 23. Okay, just in the middle. Okay, I think Turkey is still somewhere there, in terms of productivity, or maybe a little higher now. Okay, yeah, fantastic. Thank you. Exactly. That's where Turkey was. I could not see properly. Exactly. Yeah. So I think this is fantastic data. And I mean, if somebody want to study this kind of break in the last 70 years, this can tell what can happen to the fortune of different countries. All got upside down. Okay. Anyway, okay. So that's what I thought it's very interesting data that Minas used. Okay. Next slide, please. Okay. But then what happened? He presented this result in the Stanford seminar. People said, okay, look, it's good, lots of regression. That's it. Nothing exciting. And then Arrow was in MIT. Then he moved to Stanford in January 1959. So remember, he went to Stanford in 1957 summer, and then so this is like we are talking about in his 4th year of PhD. Okay, in his 4th year of PhD. Okay, and then Arrow said he looked into his little paper he wrote, and Arrow said that the results are extremely interesting. Okay, that's Arrow saying that. And in fact, when I talked to Arrow in his office, that's what he still remembers, that looking over Minas this working paper. And now for the first time in his academic life, somebody is saying that his results are extremely interesting. And all the time, Illinois, everybody, nobody think anything about him. He was the kind of, student in the bottom of the class. And in Stanford, he didn't take any classes, but people are not so excited about his research. And Arrow said, okay, no, this is interesting, extremely interesting. Okay. And again, Arrow was already very famous that time. Arrow got his PhD in 1949, and he wrote, fantastic paper on lots of areas. So Arrow was already pretty well known, within the 10 years after his PhD. Okay, so for the first time in his life, Minhas is getting some kind of encouragement. Okay, next slide. Okay, so this is exactly what Arrow sent a note to Minhas. He said, okay, no, fantastic. What you are saying that your data does not your data are not supporting the Cobb-Douglas hypothesis. That's good, but that's not enough. Say that no, Cobb-Douglas is no good. Then Arrow said what he needs to do or what they need to do, that have alternative hypothesis. Now it is completely in a testing framework that Minhas empirical result says that we have to reject Cobb-Douglas in certain sense, because the data tells a different story. But now Arrow puts the right question, that if the data is not fitting the Cobb-Douglas, then what kind of function the data will match? That means alternative hypothesis, that you have to come with an alternative. So you can see the approach Arrow is doing. And this could not have been done by Minhas, because Minhas has actually no mathematics idea. He has no idea of the model. He can just tell with his regression that Cobb-Douglas is not good enough for certain data. Okay, so that was the Arrow suggestion, and that is the kind of big breakthrough. So now two breakthrough. First breakthrough, when Minhas got the idea of that Cobb-Douglas should be tested from observing the hair cutting saloon or the cornfields, how the corn and soybeans are produced in United States or in Illinois compared to India. Okay, so the conception was there, but then nothing much happened except these empirical results. Now Arrow is kind of asking the right question. So that's what it is, that you have to ask the right question, and that is the role of sometime what we can call your research guide. Okay, otherwise there won't have any CS production function for a long time. Okay, so let us go how it is going towards the CS production function. So this is the second major step. Okay, next slide. So then Arrow had some kind of little mathematics result. I'll come to that. And again, around the same time, Solo wrote a paper. Basically, Solo is saying, no, look at, sigma cannot be 1. Sigma should be 2. But at least again, he was asking the same kind of question, that Cobb-Douglas may not be right, but he got a very weird result, empirical, that no, sigma is not 1, but sigma is 2 for certain data. But again, it's questioning the Cobb-Douglas. Okay, next slide. Yeah, next slide, please. Yeah, next slide. Okay. Now, I won't go to the math. I'll tell you. What happened, look at the number 1. That is the regression Minhas was running. Beta came many cases different from 1. So this is the work, like a less than a page math work was done by Arrow. So he starts with the Minhas regression, and he leaves beta as beta there, because beta is equal to 1 is Cobb-Douglas, we know. Then he simplifies the notation. He puts whole thing in mathematical, basic undergrad math. So he puts V by L y, K by L x, and then he writes that, equation. As you can see, he writes the equation as a general form. Y is equal to fx. No linear function. See, look at no linear function. So he introduces non-linearity, that your V by L is a non-linear function of K by L. But he does not know what the function is. Then he writes that, equation 1, using this notation of x and y, into, look at the middle of the slide, that he converts 1 into a differential equation. So 1 is equivalent to a differential equation, keeping beta there. Okay, keeping beta there. Okay, and all of you have learned this solving differential equation in your undergraduate math class. Okay, so you solve that differential equation, and then look at this, what you get. You get a solution. Then again you put back y is equal to V by L and x is equal to K by L. Then look at the last but one equation, and that is your CS production function. Okay, can you see that? Okay, so this is less than a 1-page derivation, and now this is the foundation of the CS production function. How it took, it's a long journey from the cornfields of India to the cornfields of Urbana-Champaign, then all the way to California, Stanford. Okay, and so this, as you can see, there is no high mathematics at all. But the steps, they don't look, big, profoundly mathematically, challenging. But this is a big step. Okay, so what I will call, it was a single step kind of for arrow, but it was, huge for the whole, the econometrics. So this is the way we went from number 1 equation, the linear, to CS, which is a highly nonlinear. It is one of the most extremely nonlinear model. Okay, so this is the mathematical foundation. So now you can see how we got into this, CS production function. Conception at the cornfields of Illinois, and then the result was in Stanford. Okay, the next slide, please. Okay, so this happened in 1959. There was the Econometric Society meeting, and I saw this announcement, and then they presented this paper at that 1959 meeting. And as you can see, this is the conference, excuse me, the session, and it was the kind of, as you can see, the last paper. And even this paper, as you can see, the Mina's first name was kind of, printed wrong. The Bagicha was completely, mistaken. Okay, because everybody knew who is Arrow, who is Chenary, who is Solo, but nobody knew Mina's. So, but Arrow, presented this paper at the Econometric Society meeting in 1959 December. Okay, next slide. Okay, now this abstract is not in the published paper. Okay, so, and I mean, if you have time, you read this abstract. This abstract was, I am sure, written by Arrow, and this is, like, I would say, the best abstract ever written in economics. Look at the keywords. First, he goes into the data. Okay, then with the data, they try to test the Cobb-Douglas production function. Then they say that the data cannot be explained by the Cobb-Douglas production function. Then they find out, a kind of a mathematical expression where the data can matches the model. The model is the CS production function. Okay, because it is very flexible. Now you don't have to put sigma is equal to 1. It could be anything. Now it can be 0, it could be less than 1, or even greater than 1. And then they repeated the exercise, what he called at the end, the empirical test. Both time series as well as cross-section data. Okay, and so this paper was published in 1961 in the Review of Economics and Statistics. Okay, but of course, none of our graduate students read that paper anymore, because they look at the textbook CS production function, that's it. But it is good to know the root of the CS production function, how it came into being. Next slide, please. Okay, so maybe I have taken a long time, so maybe I should be finishing soon. So let me I'll stop here. So the Minas taught at Stanford after finishing his PhD for 1 year. Then he went back to India to get a job. He got a job at a very famous institute. It's called Indian Statistical Institute, a institute which was established by a famous Indian statistician called Prashanta Chandra Mahalanobis. You might have heard of this called Mahalanobis D-square. So the same statistician, and this is a very premier institute. That time, even that time, it was one of the best statistical center in the whole world. And so he got the job there. And when I was a student, Minas was a teacher at Indian Statistical Institute, what we call ISI. Okay, but he didn't teach me directly, but I saw him there a lot of times. Okay, and I will end with this. Minas had a difficulty in getting a job at ISI. Although the paper was published in 1961, but when the statisticians and mathematicians of ISI looked at his paper, they thought it is so trivial, because they're looking at the math part of the paper. But the math part of the paper I shown you, it is less than a page, and it is undergrad math. They said no, this paper is not very rigorous. Okay, so the mathematician, they didn't want to employ Minas into ISI. Okay, but only Mahalanobis, because he understood what is the implication of the CS production function. So he override, because he was the director. Then he employed, over the objection of his younger mathematicians, and to ISI. And then Minas became very, very famous, and he became the fellow of the Econometric Society. In fact, he is the first fellow of the Econometric Society from India. And then he did a lot of other things. And so I think I have many more slides, but let me stop here. So I hope I have been able to give you the message about not just CS production function, but how people can get an idea from a very kind of unlikely source. And once you follow that idea, and with the right kind of help, you can come up with something which is very, very profound. Okay, and now we cannot do econometrics without CS production function. Again, as I'm saying, it is the first nonlinear function. Okay, first nonlinear function. That the switch from the linear to nonlinear, it's a huge step. It is like, I can compare these steps to like people landing in the moon. Okay, So now you see how the ideas come from, where do they come from. And so this talk is more targeted towards the PhD students and the junior faculty who are looking for new ideas in economics. Okay, thank you. I'll stop here and you can ask me any question. And it is only my 9:39 a.m. It is only morning. I know yours is like evening, and you might be thinking about going to dinner or at least to have some drinks. Okay.
Sir, thank you very much for your very expanded presentation. We both how these econometric functions are growing from time to time. It's a very long journey, like it's more than a 60 years journey coming from India and processed in United States and extended to whole world. This econometric functions. I admire. Thank you very much for your presentation again.
Okay. Thank you. You're welcome.
Are there any questions for Professor Bera, sirs and ma'ams? If yes, I will wait only a minute. You may also write it on the chat site, which is on the right. Let me check it out for you, sir. No, that's the message I've written. Okay. Sir, I want to thank you again to join our conferences. Hope to host you in Turkey right after pandemic. We will be very happy to host you again in Turkey and on our conferences. Thank you very much. I may take your last words for this session. Thank you, sir.
Okay, thank you, sir. Thank you so very much. Okay, yeah, thank you. Yeah, I really enjoyed, Yeah, I wish I could be there in person, but this is what we can do, given the circumstances. Thank you.
Exactly. Thank you. Dear all, we are about to finish this session, this special session with Professor Anil Bera. I want to thank you to all for being part of this special session with Professor. Now, I'm closing this session. I wish you all the happy and healthy weekend and a very successful conference. Thank you very much. Have a good night in Turkey. Thank you. Bye-bye, sir.
Bye-bye.